Hi, welcome to our discussion on the mole. The mole is actually a unit, okay? It's the SI unit, so it's in the metric system, and its abbreviation is MOL. Yes, you get to drop one letter off of the word for the abbreviation. The mole is equal to the atomic mass in grams of any element, okay? So what that means is any of these atomic masses down here are equal to a mole of that element. Okay, so let's see. For example, let's look at carbon. All right, carbon has a atomic mass of 12.011. Okay, that means that 1 mole of carbon is equal to 12.011 grams of carbon. All right. There's also another piece to the mole, and that's going to come by way of Avogadro's number. Okay, there's a scientist named Amadeo Avogadro, and he's widely given credit for coming up with this number right here. In actuality, that's not really true, but he's given credit for it. And it says that the number of particles, atoms, or molecules, and we really do need to add that in here, so or molecules, okay, in 1 mole of a substance is equal to 6.02 times 10 to the 23rd. Okay, that is a number that you're going to need to memorize. Okay, so the mole is equal to the atomic mass in grams of any element, and also 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles, atoms, or molecules of that substance. Okay, so right down here I have given you both of those written out. Okay, and hopefully you notice that both of these things have equal signs in them, and we remember that anytime we have one thing equaling another thing, we are looking at a conversion factor. Okay, so that means we're probably going to be using this in dimensional analysis as conversion factors. Okay, one more thing is that the molar mass of any element must be equal to grams per mole in the unit. Okay, what I mean by that is if 1 mole is equal to the atomic mass in grams, then that must mean that the atomic mass has a unit of grams per mole, so that the moles would cancel out and leave grams behind. Okay, so anytime that we look at the periodic table and see any of these atomic masses here, the unit of all of these atomic masses is grams per mole. So carbon has a molar mass of 12.011 grams per mole. Okay, and so you need to know that the unit for atomic mass is always grams per mole. Okay, so let's do some example problems where we use our new conversion factors. So a normal problem that you may see would be something like this. How many gold atoms are in 5.0 grams of gold? Okay, so just like any other dimensional analysis problem, we're going to put the given over 1. So we're going to take our 5 grams of gold and put that over 1. And whatever unit you have on the top is the same unit you have to have on the bottom. So we're going to bring grams of gold down on the bottom. Now, where are we going to get our new amount of grams of gold? Okay, anytime that you see grams of either an element or a compound, you have to go to the periodic table to find the answer. Okay. Alright, so here's the periodic table, and then we're going to focus in on gold here, and we see that we have 196.97 as our atomic mass or molar mass for gold. Alright, Okay, so we're going to put 196.97 down here, and that is equal to 1 mole of gold. Okay? So here's the conversion factor that we just used, okay? The atomic mass in grams of any element is equal to 1 mole of that element. So the atomic mass in grams of any element is equal to 1 mole of that element. Alright? But you'll notice they didn't ask me for moles, they asked me for atoms. Okay? And any time that you see the word atoms, particles, or molecules, you're going to use Avogadro's number. So we did not get to the unit that we were asked to get to yet, so that means we're not done. We have to put another bar down here. And whatever unit you have on the top is the same unit you have to put on the bottom, as always. So I'm going to put moles of gold down here. And anytime that you are talking about moles and you're wondering how many moles go there, it's always 1. Okay? And here's why. If you look at our conversion factors, it's always 1 mole is equal to something else. 1 mole is equal to something else. Okay, so anytime you're wondering, oh, well, how many moles do I have? It's going to be 1 because our conversion factor is always relating it to 1 mole. Okay, so we can say that 1 mole of any element is equal to 6.02 times 10 to the 23rd atoms, molecules, or particles of that element. So right here we've got 1 mole of gold is going to be equal to 6.02 times 10 to the 23rd, extend that, atoms of gold. Okay, and so now we just multiply across the top and divide along the bottom so that we can get our final answer. Okay, so take a second and see if you can figure that out for yourself. Alright, I get 1.528151 times 10 to the 22nd atoms of gold. Okay, now we need to make sure we pay attention to significant digits. You always get your sig figs from your given. So since there's a decimal in this number, we start on the left hand side, find the first non-zero digit, which is 5. We count that and everything after it. So there are 2 sig figs here. There's a decimal in this number, so we start on the left, find the first non-zero digit, 1. The second one is a 5. We see if the third place value rounds the second place value, and it does not. So we're going to stick with 1.5 here. So we've got 1.5, and then we have to put the rest of this on here. 1.5 times 10 to the 22nd. And then we always need a unit because we don't allow naked numbers, atoms of gold. Alright? So there's the final answer on that one. Alright, let's try this second example. What mass of gold contains 25,000 gold atoms? Alright, so obviously this is our given because that's the only number that we have. So we're going to put that over 1. Okay, 25,000 atoms of gold over 1. And whatever unit you have on the top is the same thing you have to have on the bottom. So I'm going to bring down atoms of gold down here. And remember I told you just a minute ago, anytime you see atoms, particles, or molecules, you're going to have to use Avogadro's number. So we're going to bring that down. 6.02 times 10 to the 23rd. That's Avogadro's number. And what is that equal to? Remember, Avogadro's number is equal to 1 mole. So we can say 1 mole of gold on top. But they didn't ask me for moles, they asked me for mass. Okay? Well, what is mass measured in? Okay, mass is measured in grams. Alright, so they're asking me how many grams of gold are in 25,000 atoms of gold. So that means that we're not done. We have to keep going. So I'm going to bring that out. And whatever unit's on the top, the same unit I have to have on the bottom. So I'm going to bring down my moles of gold. And how many moles of gold? Well, remember, anytime we're wondering how many moles of something we're talking about, it's always going to be 1, because that's what our conversion factor has in it, 1. Okay, so now we need to know the molar mass, because any time that we see the word grams, we know we have to go look at the periodic table. Okay, well, I'm going to skip that part because we already looked at the periodic table earlier and we saw that this was the molar mass of gold. So I'm going to bring that down here. 196.97 grams of gold is equal to 1 mole of gold. Alright? So now we multiply across the top and divide along the bottom. So you take a second and see if you can figure out what that is. Okay, I'm coming up with 8.179817 times 10 to the negative 19th, and that would be grams of gold. Now we need to do sig figs. How many sig figs does this number have in it? Okay, there's no decimal in the number, so we're going to start on the right hand side, find the first non-zero digit, which would be 5, count that and everything after it. So there's 2 sig figs in that number, so we can only have 2 sig figs in this number. This number has a decimal, so we start on the left hand side. 8 is the first non-zero digit, 1 is the second, and that's where we would stop. But you have to look one place value further and see, does this 7 round up the 1? And yes, it does. So our final answer is going to be 8.2 times 10 to the negative 19th grams of gold. So hopefully you got the same answer. Okay, let's look at a third example. How many oxygen atoms are contained in 100 grams of Al2SO3, close parentheses 3? Okay, well, let's pick out a few things that I've told you to be on the lookout for. We see the word atoms, and as soon as you see atoms, particles, or molecules, you know you're going to have to use Avogadro's number. Okay, and then I also told you to be on the lookout for grams. Anytime we see grams, we know we're going to have to look at the periodic table. Okay? So if we just know that up front, that will help us throughout our problem, and we'll realize, hey, I haven't looked at the periodic table yet, that means I'm going to get the problem wrong. Okay? Now this right here is a little bit different than what we've had to deal with before. We've got an entire compound there, or entire molecule, and we haven't done that yet. So let's talk about that. The 3 on the outside is going to multiply everything on the inside. Okay? So that means that there are going to be 3 sulfurs and there's going to be 9 oxygens. Okay? And these are all molar values. Okay? There's 2 moles of aluminum in this 1 mole of the entire molecule. There's 3 moles of sulfur in 1 mole of the entire molecule. And there's 9 moles of oxygen in 1 mole of the entire molecule. Okay, so we really have 9 moles of oxygen here. Alright? So we're going to use that in a second. Okay? And we've got 100 grams of that stuff. Okay? Whatever that stuff is. So that's obviously going to be our given. So we're going to take our 100 grams of this stuff and put that over 1. Okay. Now, anytime we have grams here, we have to look at the periodic table. But we don't just have one element, we've got a whole bunch. of elements there. And we need to add them all up. We need to add the masses of all of these elements together so we can have the total mass of that compound. So this is what I call breaking it down. Okay? And so we're going to write out each element that we have. We've got aluminum, we've got sulfur, and we've got oxygen. Okay? There are 2 aluminums, and we need to go see what the molar mass of aluminum is. Okay, so aluminum has a molar mass of 26.982. So we're going to put the 26.982, and remember that's grams per mole is the unit for molar mass there. Okay, and now we need to do sulfur. So we said that this 3 here is going to multiply inside, so we've got 3 sulfurs. So we're going to say 3 times, now we need to go find the molar mass of sulfur. Okay, so sulfur is 32.065. So we're going to put that right in here. And make sure to include the unit. And then oxygen. We've got 3 times 3 oxygens, and that gives us 9 oxygens, and we need to go get the molar mass of oxygen. Okay. So we've got 15.999 grams per mole of oxygen. Okay. So you're going to go through and multiply each of these things, and then when we're done multiplying, we're going to add all of it together so that we can have the total mass of this entire compound here. Okay, so up until now we've just looked at the periodic table to get the mass of a single element, but this time we were given not a single element but a compound that has several elements in it. So you have to add all of their stuff together. So I want you to take a second and go through and multiply these numbers first and then add all your answers together so we can see what that is. Okay, I came up with 294.15 grams per mole. And now we say grams per mole of what? Well, when we add all of this stuff together, we're getting that molecule right there. So it's going to be grams per mole of that stuff. Okay? Alright, cool. Now, we have grams per mole, or excuse me, we have grams of this stuff up here on top, which means we have to have grams of that stuff down here on the bottom. And we need to know how many grams go down here. Okay, well, we get that from right here. Okay, the way to read this, we have 294.15 grams of this stuff is equal to 1 mole of this stuff. I want to talk to you for a second about this grams per mole. Let's say that you go to the gas station and they're selling gas for $3.15 per gallon. Okay? Well, when you see this, you see $3.15 on this side, and you just see gallons on this side. There's no number over here. So how many gallons are they talking about? Okay, well, it's 1 gallon. You're going to pay $3.15 for every 1 gallon of gas that you pump into your car. Alright, so just like over there, when we have 294.15 grams of that stuff is equal to 1 mole of that stuff. Okay, even though there's not a number on the other side, when we write it like this, this is just kind of a way to shorten it so we don't have to write this big long conversion factor every time. So even though we don't have 1 right here, we know that that's true. Okay, it's the same thing as all other conversion factors like that. Okay, so this is $3.15 for every 1 gallon. This is 294.15 grams for every 1 mole. So we're going to bring that number up here then. 294.15 grams of that stuff is equal to 1 mole of that stuff. Alright, well they didn't ask me about moles of this, they asked me about atoms of oxygen. Okay, so we got to keep going. Okay, now earlier we said that there are 9 moles of oxygen in 1 mole of this whole thing. And that's the next conversion factor that we're going to use. Okay, whatever unit you have on top, same unit you have to have on bottom. So we're going to bring moles of this stuff down. And how many moles? The answer to that question is always 1. Okay, so 1 mole of the whole thing is equal to 9 moles of oxygen. Okay. Alright. So we're going to keep on going because we have moles of oxygen on top, but we need atoms of oxygen. So whatever unit you have on top, same unit you have to have on bottom. So I'm going to bring down moles of oxygen. And how many moles? The answer to that question is always 1. Okay. And now we've got to get atoms of oxygen. And we remember, anytime we see the word atoms, particles, or molecules, you use Avogadro's number. So we're going to put Avogadro's number on top. And we're done. So we put our equal sign. The reason I know I'm done is because I've ended up with atoms of oxygen, and that's what they originally asked for. So now it's just a simple matter of multiplying across the top and dividing along the bottom. Okay, so you take a second, go through and see if you can figure that out. Okay, I come up with 1.841917 times 10 to the 24th atoms of oxygen. And I need to pay attention to sig figs. There's a decimal here, so I start on the left. I've got 1, 2, 3, 4. 4 sig figs. So down here, we've got 1, 2, 3, 4. And then this 9 rounds the 1 up. So the final answer then is going to be 1.842 times 10 to the 24th atoms of oxygen. So hopefully you got the same answer. Okay, so here's a practice question for you. This is not in your notes packet like the other ones were, so this is just for those of you watching my video tutorials. How many moles are represented by 11.5 grams of this compound? Okay, I'm going to give you a few little hints here. You see grams, so that's supposed to give you a hint on where you're supposed to look. And we've got a whole big compound here, and so I'm going to tell you right now up front, you're going to have to break it down. Okay, so take a second, go through and see if you can figure that out on your own, and then we'll come back in and I'll have the work for you. Okay, here's what I got. I put my given over 1. I had grams of this stuff on top, which means you have to have grams of that stuff on bottom. Anytime we see grams, we have to look at the periodic table. Since I have an entire compound instead of an element, I have to break it down. So I did, and I came up with this as the molar mass of that compound. the molar mass of any compound or element is equal to 1 mole of that, and that's what they asked me for, so I was done. So you multiply on the top and you divide along the bottom, and we end up with this, and then I have to do sig figs. There are 3 sig figs here, so we have 1, 2, 3, and then I look at the next place value over and it rounds the 9 up to a 10. So I brought down the 0 from the 10, we add 1 more to the 4, which gives me 5, and so here's my final answer for that question. So hopefully you got the same thing. Alright, let's do one more. Okay, what is the mass of 9.3 moles of SiH4? Okay, what is the mass? So I'm giving you some hints here. Mass is measured in grams. And anytime you see grams, you're supposed to do something, so see if you can remember what that is. And then they have moles here, alright? Take a second and see if you can figure that out. Okay, here's what I have. I put my given over 1. It was in moles of this stuff, so moles come on the bottom. How many moles? The answer to that question is always 1. They asked me for mass, which is grams. Anytime I see grams, I'm going to have to look at the periodic table. And since this is not an element but a compound, that means I'm going to have to break it down. So I did and came up with this as the molar mass of that stuff. Then we are ready to multiply across the top, divide along the bottom, because they asked for grams of that, and that was the final unit I got. So here's the answer, and then I need 3 sig figs. So I look here, we've got 1, 2, 3. Does the next one round the last one up? Yes, it does. So I end up with 299 grams of SiH4, and hopefully you got the same thing. Alright, if you have any questions, please see me for tutorials on this subject, and thank you for learning with me. I'll see you next time.